After knowing typical features and data types of redis, next, we need to know some optimization operations in redis. There are some basic principles when conducting optimization in redis. First, we need to simplify key names and values. The key name should be as simple as possible, but do not use incomprehensive key names just for saving space. And if the number of key values is fixed, the values can be represented by 0 and 1, for example, male, female, or right, wrong. If data persistence is not required in service scenarios, disable all data persistence modes and achieve optimal performance. Redis provides two internal coding methods for each data type and can automatically adjust the coding method in different scenarios. Slowlog is one of the key monitoring instructors of Redis performance. It records queries whose running time exceeds the threshold value. The parameter slowlog logged slower than determines the threshold value, which is set in microsecond level. It means that the commands whose execution time is larger than the value specified by the parameter will be recorded. And slowlog max len determines the maximum number of logs that can be saved in slowlog. When Redis dumps data, a child process is forked. Theoretically, the memory occupied by the child process is the same as that occupied by the parent process. For example, if the memory occupied by the parent process is 8 GB, 8 GB memory need to be allocated to the child process. If the memory cannot be allocated, the Redis server will break down or the I/O load will be too high, which reduces the efficiency. Therefore, the memory allocation policy should be set to 1, indicating that the kernel allows all physical memory to be allocated regardless of the current memory status. We can add vm.overcommit underlying memory to 1 to the system configuration file called syscontrol.configuration and restart the server. Or run the syscontrol vm.overcommit underlying memory to 1 command to modify the memory allocation policy. Transparent huge pages, short for THP, is used to improve memory management performance, but it may cause memory locks and thus affect Redis performance. So it is recommended that this function be disabled, and THP is not supported in 32-bit RHEL6. It is not difficult to disable THP, just run such command as user root to add related content into the file rc.local. Sometimes we can modify the maximum number of TCP connections in Linux to improve the performance. This parameter determines the length of a completed queue in the TCP connection. Here, completed means after 3-way handshake. The value must be less than or equal to the value of SO max connection defined by the Linux system. The default value is 511 for Redis and 128 for Linux. When the system has a large number of concurrent requests and the client responds slowly, we can set the values by referring to these two parameters at the same time. The command is shown in the slide here. Please note that this parameter does not limit the maximum number of Redis connections. The default value of maximum connections is 10,000, and if we want to change it, then we may need to modify the value of parameter max clients. If the total data volume is not large and the memory is sufficient, we do not need to limit the memory used by Redis. But if the data volume is unpredictable and the memory is limited, then we can limit the memory used by Redis to prevent Redis from using the swap partition or prevent OOM errors. Actually, if the memory usage of a Redis instance exceeds the maximum available memory, the operating system starts to exchange the memory with the swap space and write the old or unused content in the memory to disks. In this way, new physical memory can be released for new pages or active pages. However, the read or write operation on the hard disk is about 5-fold slower than that on the memory. If memory swapping occurs on Redis process, the performance of the Redis and applications that depend on Redis is severely affected. Please note that if memory is not limited, the swap partition will be used when the physical memory has been used up. In this case, the performance is low. If the memory is limited, data cannot be added after the specified memory is reached. Otherwise, an OOM error is reported. In Redis, there are two key parameters related if we want to limit the memory. They are max memory and max memory policy. Max memory indicates the maximum memory, And max memory policy indicates the data clearance policy when the memory is insufficient. If max memory is not set or set to 0, the memory size is not limited in a 64-bit system, and the maximum memory size is 3 GB in a 32-bit system. Also, we can run the info command of redis to view the memory usage. Redis is a single-thread model. Commands from client are executed in sequence. Therefore, we can use pipelines or commands that are able to add multiple pieces of data at one time to improve performance. For example, we can use mset to set multiple keys at a time rather than use set for multiple times. Other commands that can add multiple data are listed in the table here. In this section, we talk about some optimization operations, and next, we will see a typical case in which redis is used.